TFFN wire is a type of building wire commonly used in electrical applications. Understanding the designations used for different wire types is crucial for electrical work to ensure safety and compliance with electrical codes. The letters in TFFN each represent specific characteristics of the wire's construction and insulation. The first T in TFFN indicates that the wire has thermoplastic insulation. Thermoplastic insulation is a type of polymer that softens when heated, allowing the wire to be bent and shaped easily during installation. This type of insulation provides good electrical insulation and is resistant to moisture and abrasion. The second F in TFFN signifies that the wire has a flexible stranding. Flexible stranding means that the wire is made up of multiple small strands of copper instead of a single solid conductor. This construction provides increased flexibility, making the wire easier to pull through conduits and around corners. The third F in TFFN does not stand for anything specific in the context of wire designations. The N in TFFN indicates that the wire is nylon coated. Nylon is a tough and abrasion-resistant material that provides an additional layer of protection for the thermoplastic insulation. The nylon coating helps to prevent damage to the insulation during installation and use, extending the life of the wire. Different types of wires are designated with letters which correlate to a variety of insulation and sheathing types. Common wire types include THHN, THWN, and XHHW, each with its own unique properties. THHN wire features thermoplastic high heat resistant nylon insulation. THWN wire features thermoplastic heat and water resistant nylon insulation. XHHW wire features cross-linked polyethylene high heat and water resistant insulation. When working with electrical wiring, it is crucial to follow all applicable electrical codes and safety regulations. Incorrect wiring can lead to electrical hazards, including shocks, fires, and equipment damage. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring. When selecting wire for a specific application, consider the following factors. Firstly, the ampacity of the wire, which is the maximum amount of current that the wire can safely carry. Secondly, the voltage rating of the wire, which is the maximum voltage that the wire can withstand. Thirdly, the environmental conditions in which the wire will be used, such as temperature and moisture. Fourthly, the type of insulation and sheathing required for the application. Fifthly, the size and type of conduit or raceway that will be used to protect the wire. In addition to TFFN wire, there are many other types of electrical wires available, each designed for specific applications. Some common types of electrical wires include non-metallic NM cable, underground feeder UF cable, and armored AC cable. NM cable is commonly used for residential wiring and typically contains 2 or 3 insulated conductors plus a ground wire. UF cable is designed for direct burial in the ground and is often used for outdoor lighting and irrigation systems. AC cable features a flexible metal jacket that provides mechanical protection for the conductors. The National Electrical Code, or NEC, is a set of standards for safe electrical installation and wiring practices. The NEC is updated every 3 years and provides detailed requirements for all aspects of electrical work, including wire sizing, overcurrent protection, and grounding. When working with electrical wiring, it is essential to follow the NEC to ensure the safety of people and property. Wire size is an important factor in electrical wiring. The size of the wire determines the amount of current that it can safely carry. Wire size is typically measured in American wire gauge, or AWG. The smaller the AWG number, the larger the wire size and the more current it can carry. For example, 12 AWG wire is larger than 14 AWG wire and can carry more current. It is crucial to select the correct wire size for the intended application to prevent overheating and electrical hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to the wiring and equipment. Overcurrent protection devices should be properly sized to match the ampacity of the wiring they protect. Grounding is an essential safety feature in electrical systems. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing an electrical shock. Grounding systems typically consist of a grounding electrode, such as a ground rod or ground plate, connected to the electrical panel and all metal enclosures. Proper grounding is essential for the safety of people and equipment. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes are available in a variety of sizes and shapes to accommodate different wiring configurations. Electrical boxes should be properly sized and installed to provide adequate space for the wiring and connections. Conduit is a type of tubing used to protect electrical wiring. Conduit can be made of metal, plastic, or fiberglass. Conduit provides mechanical protection for the wiring and helps to prevent damage from moisture, chemicals, and other environmental factors. Different types of conduit are available for different applications, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Wiring devices, such as switches, receptacles, and dimmers, are used to control and distribute electricity. Wiring devices should be properly installed and connected to ensure safe and reliable operation. Wiring devices are available in a variety of styles and colors to match the decor of the room. Electrical safety is paramount when working with electrical wiring. Always to energize the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, consult with a qualified electrician. Electrical permits are often required for electrical work. Check with your local building department to determine if a permit is required for your project. Electrical inspections are conducted to ensure that electrical work meets the requirements of the NEC and local codes. Electrical inspections help to ensure the safety of people and property. Troubleshooting electrical problems requires a systematic approach. Start by identifying the symptoms of the problem and then use a multimeter to test the voltage, current, and resistance of the circuit. Consult with a qualified electrician if you are unable to resolve the problem. Electrical maintenance is essential for ensuring the safe and reliable operation of electrical systems. Regularly inspect electrical wiring, connections, and equipment for signs of wear and tear. Replace any damaged or worn components promptly. Keep electrical panels and equipment clean and free of dust and debris. Consistently checking for any signs of wear and tear or other deficiencies will help avoid future problems. The electrical industry is constantly evolving with new technologies and innovations. Stay up to date on the latest developments in electrical wiring equipment and safety practices. Attend industry events and training courses to enhance your knowledge and skills. Learning about new technologies will help improve one's electrical work and knowledge. Electrical apprenticeships are a great way to learn the electrical trade. Apprenticeships combine on-the-job training with classroom instruction. Apprentices typically work under the supervision of a licensed electrician and learn all aspects of electrical wiring, installation, and maintenance. Upon completion of an apprenticeship, you will be eligible to take the licensing exam to become a licensed electrician. Licensed electricians are qualified to perform electrical work in accordance with the NEC and local codes. Licensing requirements vary by state and locality. Check with your local licensing board for more information. Electrical contractors are businesses that provide electrical services to residential, commercial, and industrial customers. Electrical contractors typically employ licensed electricians and other qualified personnel. When hiring an electrical contractor, be sure to check their credentials, insurance, and references. Doing this will help avoid potentially dangerous circumstances. Electrical engineers design and develop electrical systems and equipment. Electrical engineers work in a variety of industries, including power generation, telecommunications, and manufacturing. Electrical engineering requires a strong understanding of mathematics, science, and engineering principles. Electrical technology is a field that focuses on the practical application of electrical engineering principles. Electrical technicians work with electrical engineers to install, maintain, and repair electrical systems and equipment. Electrical technology programs typically cover topics such as electrical wiring, electronics, and industrial control systems. Learning about TFFN wire and other types of electrical wiring is essential for anyone working in the electrical field. Understanding the different types of wire, their properties, and their applications is crucial for ensuring the safety and reliability of electrical systems. By following the NEC and other applicable codes and standards, you can help to prevent electrical hazards and ensure the safety of people and property. And as a reminder, when working with electrical wiring, it is essential to follow all applicable electrical codes and safety regulations. Incorrect wiring can lead to electrical hazards, including shocks, fires, and equipment damage. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring.